welcome to the power system protection course. In the relay lab we are now. Today's demonstration is on PMUs, how they are being connected to the grid and how they provide synchrophasor data and how those data can be analyzed for application. So, in this experiment in the relay lab we have few PMUs and for that we have a setup and these PMUs are connected to the grid. So, particularly for this experiment we will show how the two PMUs are being connected to two buses and how they provide the corresponding angle, the delta angle in real time and the corresponding voltages and current which are being time stamped provide us the synchrophasor data. So, for this we have the PMU connection arrangement, the laboratory setup and demonstration. We will have an example of how to obtain the transmission parameter for the particular network given. In real time we can have that and how we can obtain the corresponding parameter in a transmission and in actual systems, corresponding sample calculation and overall conclusion. For that perspective, as you know, in our lectures also we have seen that a PMU, intelligent electronic device like any numerical relay which has the additional features of time information from the GPS. For that we have this GPS antenna and this GPS antenna provides us the corresponding atomic clock based time information from the satellite. It goes to this GPS receiver to the PMU which has the corresponding A to D conversion process and all these things. So, the PMU time information is being controlled by this time received from this GPS receiver. Every 1 second it receives the corresponding time and the corresponding position of the satellite. Now, the corresponding voltage, current, all the analog inputs are being fed to the corresponding PMU through PTs and CTs and the A to D conversion process samples it and then the phasors are being calculated using DFT or so as already mentioned. So, then the corresponding phasor values are being time stamped in addition to the frequency and rate of change of frequency or any other informations which are to be sent to a particular destination. Once the corresponding phasors are being time stamped and the frequency, rate of change of frequency are being obtained, the PMU sends information to the PDC through the phasor data concentrator through the dedicated communication system that such data are continuously being monitored at particular substation level or at the other super PDC level and so and are being used for monitoring, control and protection application. Now, in this experiment we have a simple demonstration which will convince us that how the PMU is being useful for grid monitoring, analytics and so. So, we have 2 bus systems as already mentioned. So, in these 2 bus systems we have this one is the synchronous generator side which feeds power to the grid via this line section and the other side of the line a different bus which is being the grid side. So, the grid side is having 400 volt 50 hertz systems and these are fed from the distribution system and we have a connection of the PMU at the grid side bus and another PMU connection at the synchronous generator side. This synchronous generator is being controlled by this corresponding excitation systems for its reactive part inject to the grid and the corresponding real power is being controlled by these mechanical drive systems for the arrangement to the alternator. These two PMUs are connected via the local area network to our PDC, and the PDC happens to be the corresponding the PC, and this PDC collects data from both the PMUs simultaneously to the local area network, and through that we can monitor the corresponding two buses voltages and the corresponding currents continuously using this PMU data. As such, we know that the PMU provides the timestamp synchrophasor data and including frequency and so with the sequence voltage, currents and so, and that will be obtained from these two PMU for the experimental setup. Now, we will go to the demonstration part and obtain the corresponding data, and then we will proceed how to verify the corresponding things. Now, we will see the experimental setup with the PMUs. So, I will go one by one for that. So, as already mentioned, we have a transmission system. Each of the transmission block here if you see is having a 50 kilometer length of equivalent inductance, resistance and capacitance. So, they are being connected. So, that corresponds to a equivalent to a 400 kV transmission system network of 50 kilometer length. So, we can connect different number of blocks multiple of 50 kilometer. So, the left hand side we have the corresponding alternator. We have multiple alternators which can be connected to the grid via this transmission network, and to the right hand side we have the grid, the 400 volt 3 phase supply system that we are considering as the grid. So, grid side and the corresponding generator side, in between we have transmission network. So, this transmission network can be of length of multiples of 50 as required for the particular experiment. Now, to the alternator side, the alternator bus, we have this PMU1 connected, and to the grid side we have PM2 connected. These two PMU are arbiter make. So, this is 1133A power sentinel model, and the PMU1 is connected to this GPS receiver, where the corresponding GPS receiver provides the corresponding time signal, irregular time signal to this PMU1 and PMU2 both, or in an actual power systems for different substations they can have the different GPS receiver also. This GPS receiver is connected by this cable to the outside for the antenna is mounted outside. So, through that antenna from the satellite, the corresponding time information every second, the corresponding information of the time and the GPS position are being received by this GPS receiver, and the GPS receiver provides the corresponding time informations to these two PMU using the irregular signal as already mentioned in our the PMU lectures. Now, these two PMUs are connected to the grid via this through these PTs and CTs. However, in our case the corresponding current which we are feeding to the grid by this alternator is being limited to 5 ampere or so. So, therefore, we do not require different CTs for the connection of these currents. So, we have connected directly to this PMU for this current aspect, and the corresponding voltages are being fed via this PT connection. Now, when the setup is ready, so the corresponding alternator is to be connected to the grid after the synchronization. For that synchronization, we have synchroscope, and using the synchroscope the corresponding frequency and voltages are being matched, and then we switch on the corresponding alternator to the grid. Note that the alternator output can be controlled by this the drive systems, mechanical drive systems, that is induction motor drive, which is being controlled by this monitoring this panel, and accordingly the output of the alternator goes on changing. So, thereby the voltage the voltage is being controlled by this excitation system of the alternator DC supply input, and the corresponding output of this the delivery of the alternator in the kilowatt power is being changed by controlling the drive system of the alternator. Now, by that way what happens that the angle of the generator with respect to the grid side goes on changing, more power input to the grid from this alternator increases the delta angle between the two buses. So, that is being reflected by these two PMO, which will be showing in the demonstrations in the through the PDC after the synchronization part and so. So, in overall from this setup what we see that we have alternator which gives power input to the transmission system, which is being connected to the grid side, and the grid is having a 400 volt 50 hertz supply systems. So, we have two PMUs, PMU 1 and PMU 2, which are being connected through LAN to the PDC, and these PMUs will provide the corresponding synchronized data, synchrophasor data to our PDC platform, where you can analyze and go for different experimentation perspective. In this the experimental setup, we are verifying a simple example of how to have this corresponding parameters of the transmission system. So, as already mentioned, each block is having 50 kilometers length of this. So, we collect the corresponding data from this PDC for that observation during a steady condition, and through that we will calculate the corresponding the parameters using the particular relations in this case. So, now we will see the demonstration after the corresponding alternator is being synchronized to the grid through the transmission network. So, we see here the alternator which we are using now is this one. So, this alternator is being controlled through this panel, and it is connected to the induction motor drive, and the drive feeds the mechanical input power to the alternator, and accordingly the corresponding the output power of the alternator changes. In addition, the excitation system of the alternator current is being also changed, so that the alternator delivers different amount of reactive power to the grid, or it may draw also reactive power from the grid perspective. These alternators are being you can see the corresponding voltage variations of the grid side and so. And now, to this once this corresponding alternator is being connected to the grid through this transmission network blocks which is already there. So, PMO 1 is connected to the generator side bus, and this PMO 2 is connected to the grid side bus. Through this the GPS receiver, the antenna to which it is connected provides the corresponding timing informations to this PM1 and PM2, and now these PM1 and PM2 are being connected through the LAN to the PDC, and the PDC being in our case a PC that access the corresponding PMU both the PMU data, and that will be displaying in the next phase. So, as we have seen that the corresponding alternator is being synchronized to the grid through the 150 kilometer of length of line. So, we have two PMOs, PMU1 at the generator side, the synchronous machine side, and PMU2 at the bus, at the grid bus. So, these two PMUs are being connected through LAN to the PDC, and the PDC is this PC. So, here through this PC we will see observe the two PMUs data, and in real time. So, we will see the corresponding waveforms, the polar plot, and the corresponding angle deviations between these two PMU buses. So, first we will see the corresponding waveform. So, let us see this PMU 1, the generator side voltage waveform, the corresponding sinusoidal waveform is coming here as you see here. So, this three phase waveform is are being directly accessed to this access to this PMU to the PDC level. Now, we will go to the polar plot for the two PMU data, the voltage and current phasors. So, now we will see the two polar plots PMU 1 and PMU 2. In the polar plot, if you see here, the corresponding voltage and currents are being there for PMU 1, and similarly in the second polar plot we have this PMU 2 database polar plot where we have also voltage and current. The first PMU belongs to the PMU 1 for the generator side bus. So, if you see here the corresponding voltage here, this is voltage signal and the corresponding phase current signal here. So, the corresponding current lags the voltage by a certain angle, and this angle being observed continuously being observed here from this data. So, if you see here, this is channel A voltage, channel A current and like that, and we see here the corresponding magnitude and the corresponding angle that is varying, and the corresponding anticlockwise rotating phasors they represent for the corresponding different three phases. So, we can have the corresponding 0 sequence, positive sequence, negative sequence data also, and you see here the corresponding 0 sequence voltage being pretty small. Now, in this side, if you see this corresponding phase A voltage, it happens to be around 125 or so, and if you go to this side to the PMU 2 that belongs to the grid side voltage. So, the grid side frequency is now 50.084, and the corresponding voltage in phase A is having 133, which happens to be larger than the corresponding generator side voltage. Now, this shows that the corresponding voltage and currents are being there. Now, what happens that this line being connected to this from the both these sides. So, here if you see also that the corresponding grid side voltage being higher, it gives the corresponding charging current to the systems. So, therefore, the current is leading here in this case, and the current amount being much smaller because of this limited capacity of the system. So, therefore, we observe the system style like this. Now, this is the beauty of this PMU environment. So, we see that with the same time we can observe the corresponding angle of any phase, any sequence component both for PMU 1 and PMU 2, where the corresponding PMU 1 belongs to the generator side and the PMU 2 belongs to the grid side. Note that in reality these PMUs can be connected at different locations at different buses in a power systems, and they can be connected to the PDC through the dedicated communication system. And in our case in our lab, we have these PMUs are connected to the LAN, and they are being connected to this PC through the LAN, and through that LAN network we are being able to access the corresponding PMU data in real time and able to see the corresponding status of these different phases of both the grid side and the generator side simultaneously. Now, we will go to the how the corresponding angle between these two side buses are being monitored by this OpenPDC software. Now, we will see the angle, the delta angle between these two buses, which is the beauty of the capability of the PMU data in real time monitoring system between two buses in power system. So, we have here the OpenPDC software through which we are looking at this corresponding data, and you can have numerous options for the voltages and currents of the two buses and the corresponding lines. So, we have selected two phase A voltage, the data, the corresponding angle for the generator side and the phase A voltage of the grid side, and these you can say that angles they vary, you can say that from 0 to 180 degree as you see here, plus minus the corresponding 0 to 180 degree, and that you can say variation of the angle if you see here you can say that. So, the corresponding PMU 2 angle here you can say that the leads the corresponding PMU 1, and that you can say that angle is being monitored here. So, these if you go for these different loading condition, and so accordingly the corresponding angle between these two changes, and that we can do by input having more and more generations from the alternator. Next, we will see how these data can be downloaded into Excel file, which can be useful for data analytics and so. Now, we will see the Excel site downloaded file downloaded for this particular setup and the condition. So, if you see here the first column, A column shows the GPS local time. So, the corresponding time here you can say that see here 26th of November today's date, and the corresponding time here 1935, and this corresponding up to the second here. So, this is about that GPS, the capability of this one. So, every such instant the corresponding frequency of the particular PMU, channel A voltage, magnitude, angle, channel A current magnitude and the corresponding phase angle, and like that for the all the corresponding 3 phases, and similarly for the next PMU we have the corresponding things. So, we have positive sequence, magnitude and angle, and all details being available for this particular PMU 1 and PMU 2. So, we can download the corresponding Excel file and use this for the data analytics purpose. Now, if you see here the corresponding timestamp which is being there with the corresponding phasor data, those are being available from here. So, this is the time information for that particular phasor, and this about the corresponding frequency, phase angle, magnitude, voltage and current both. So, as we have seen in these demonstrations that we can collect the data from these 2 PMU. So, for this particular experimentation, to have a simple applications, we have the corresponding section of line being connected between the PMU 1 and PMU 2. So, this line section parameters are to be estimated. For that we collected the data of the PMU 1 and PMU 2, and the theory behind this is that we consider the corresponding transmission network model to a pi model, the series impedance being R plus jx and the corresponding shunt admittance being corresponding y 1 by 2 in both the sides. This theory also discussed in our PMU lecture also. So, here if we talk about this V 1s and the corresponding I 1s, the positive sequence voltages and currents are being expressed by this corresponding sending and the receiving end voltage and currents. If you see this sending and receiving end, the sending end here corresponds to our generator side, receiving end here corresponds to our grid side relation. So, this is about our PMU 1 the generator side PMU and the PMU 2 the grid side perspective, and the corresponding angles delta s and delta r and the corresponding theta s and theta r for the currents are as usual. Now, going to this we can find out the corresponding positive sequence impedance of the line using this voltage and current, positive sequence voltage and current, and similarly we can find out the y 1 the positive sequence admittance for this perspective using the particular relation. Here the corresponding 1 stands for the positive sequence parameter perspective. So, for that as already mentioned that after the experimentation we obtain the corresponding PMU data from both the ends. So, this is about the alternator side data and this is about the grid side data for the particular perspective. So, in this setup we have this positive sequence impedance of the line which happens to be 1.9 plus j 18.8 ohm as per this setting, and the corresponding y value happens to be in terms of this much of Siemens, j 6.92 10 to the power minus 5 Siemens. Now, using this corresponding positive sequence voltage and current data, so we compute the corresponding Z 1. You see here this about that the sending end voltage to 36 volt and with angle of minus 54.226 degree, and then using these relations we obtain the corresponding positive sequence impedance Z 1 to be 2 plus j 18.2 ohm. So, as compared to this, this is the obtained value. You see here the corresponding Z 1 2 is 1.9 18.8. So, this little bit of difference is accounted for this the corresponding CT and PT response. They are not perfect in that perspective. We do not have CT here, but we have this the corresponding PT connections, and the PTs are not perfect as such we know, and that happens also in a typical power system perspective also. Similarly, we obtain the corresponding y 1 value for this case, and the y 1 obtained you can say that happens to be the value happens to be j 1 by 2 happens to be j 7.247 in 10 to the power minus 5 Siemens, and then we compare this, they are also pretty accurate in this perspective. Thus, we see that the line parameters can be obtained pretty accurately using the synchronized data from both the ends. Note that without the corresponding synchrophasor data, which happens to be time stamped from both the ends, we cannot have such an parameter estimation of the line using both end data. So, this gives us a scope to apply in real time also by obtaining the real time data from the two PMOs from both the sides to the dedicated communication systems to monitor the parameters of this one, and such parameters are being used for the relay setting also, and also for the thermal capability of this particular line, which governs the corresponding how much power can be dispatched in real time at a particular instant and so. So, in overall we see that the PMU provides synchronized phasor data, time synchronized time stamp data, and this gives us a scope of numerous applications in for the power grid applications in terms of real time applications like protection, monitoring and control, and also data analytics and all sorts of the offline applications are also possible. So, that is what now in the power grid lot of application scopes are there, and all power grid high voltage including the distribution systems, they are incorporating more and more number of PMO in these systems. So, there are enormous scope for these PMO applications in the power grid.